Hello everyone, today's question is valid anagram. Given a two string S and T, return true if T is anagram of S and false otherwise. So let's understand first what is an anagram. So let me copy this test case and see, paste it over here and let me analyze this. So what is anagram? So anagram is like S contains what contains? It contains A appears two times, three times, sorry, in S, and then N appears three, okay, one times, then G appears one times, and M appears one times. I think it is correct. Okay. Now for the T, it will be N appears, A appears A appears two times, three times. Okay, N appears one times, and G appears one times, and M appears one times. So you can see that the frequency of every character in S and T would be same. So if the frequency of both string of a character are the same, then it is an anagram. No extra means if there S contains like J of a frequency 1, then it is not a palindrome. Sorry, it is not an anagram, and like J is extra. If here J is contained and but its frequency will be 3, so this is also not an anagram because here it is in the T, it contains J, two extra character, so this is not an anagram. So let's see how we can solve this. The very first approach is that we will sort this. We will sort both, like sort s dot begin, s dot end. Okay, and we will also going to sort t dot begin, and t dot end. And after that, if they anagram, that means they have to equal. They have to equal. So I'll say return s equal to t. If they are equal, then it will be returned true, otherwise return false. It will work. Let me run this. Although its time complexity wise not fine, but it's work. See, let me submit this if it is accepted or not. So the time complexity of this sorting will take n log n, and yeah, it is accepted. So let's try to optimize it. How we are going to optimize it? You can see, we are playing with the frequency of this both the character. If the frequency of both character are same and no extra characters in the S or in the T, then we will return anagram, we will return a true, otherwise return false. So we will create a map, or rather than we use map, we can use because in the question it is mentioned that S and T only consist of lowercase English letters. So we can create an array of size 26, and according to that we will store the its frequency. So let's see how we are going to do that. So let me count vector of count, let me name it count, and its size of 6, and initially it has all the frequency of the character will be 0. So I'll iterate for every character in a string s first. You can start with t as well. No, there is no con you can start any string with. So I'm starting with s, so it will be character or ch of s, and I'm increasing the count of ch. Okay, now what can I do for the character t? I'll just decrease. Why I'm decreasing? Let's see. If I have a character, I have a frequency of this. This is I'll process the string s first, then the frequency maps my count looks like this. Now I'll reduce the characters in the T by the frequency. If it is A contains 3 times, then it will be become 0, and N contains 1 times, then it will be become 0. G contains 1 times, it will be become 0, and M also becomes 0. And if J has extra in the T, then it will become like minus 1 cancel, then minus 2, it is minus 2. So if my final count vector contains some non-zero value, then it means it is not a valid anagram, so I have to return false. So after that I will check for int I equal to 0, I is less than, it will be 26 I plus plus. If count of I is not equal to 0, return false. Otherwise, after that, return true. Let me cut this and let's try to run this. Okay, so I have to use minus a because as the character A has a, let's suppose A has a ASCII value. Why I am doing this? Let me explain. A has a ASCII value 97, and I have to store into 26, means less than 26 size, less than 26 number. So what can I do is like I'll minus a character, so it will be 97 minus 97, and now it will becomes 0, so I can store into the size of 26. So that's it. And okay, I think it's good to run. Okay, it's running. Let me submit this. And the time complexity of this solution is I'm going to every character of S and every character of T, and assuming the character length of S will be N and character length of the string length of T will be M. So the time complexity of big O of N plus M, and iterating through 0 to 6, it will be 26, big O of 26, and it is a constant. We can consider it as a constant. So the time complexity of this solution is big O of n plus m. So that's it. Thank you.